talk about building an AI platform with Ray and Kubernetes. We'll demonstrate an application with the RAG workflow, and it'll be good times. Cool, so what's first? All right, large language models. LLMs, I'm sure all of you have heard of it. Yeah, it's all the buzz, it's everywhere. And as we're all witnessing, with these large language models, it's allowing us to apply AI to all new opportunities because of the human-like capabilities. And we're just getting started. Just curious, raise your hand if you're familiar with LLMs. Pretty much most of the room, great. Keep it up if you have it in production. That's actually not bad, 50%, more than I expected. Yeah, so one of the challenges, as you might know, 50% of you already passes, is that LLMs can hallucinate, meaning they give wrong information, right? So any AI model, including LLMs, they only know the information they're trained on. So they can't answer things that they've never seen. Or interestingly, on the other side, they remember everything they've been trained on. So even if there's some wrong information in there, they could still give that, right? These LLMs are designed to give a little bit of divergent information that allows them to have that creativity to reach the human capability. So solution, enter stage left is RAG, or Retrieval Augmented Generation. This technique actually is not that new in terms of LLMs. You can look up papers, I think it's called like neural architectural search or deep information search. And this has been used for a while in search and ranking. And Google has been using it for years. And so we have papers going back to, I don't know the exact date because I don't have my RAG set up. So. But yeah, I mean, just like an example of that is you could ask a super smart person like Kai-Hsun, hey, when's session dev 201 at Google Next? And you might remember, but even a smart human can go look at information. I'll open my Google Next app and say, oh, okay, it's tomorrow at 2:15. I actually made that up, not sure. But you should check it out. It's another session on RAGs and LLMs. So yeah, I mean, high-level architecture, right? Right now, today, you have your app. The user goes to the app, submits a query. You just feed it straight into an LLM, and the response goes back to the app, right? So basic concept. With RAG, instead, you use an embedding model, which Kai-Hsun will go over more later. You search a vector DB or an index of information. This is like your dictionary. It's literally like a dictionary, sorted and ranked. And then retrieves the comments, feeds it back into LLM, which then goes back to the app. So that is how it provides that additional contextual information to have more accurate responses. And so yeah, we're going to do a demo later, just kind of seeding this now. We are going to build a chatbot. It's still going to be kind of like a Jupyter CLI type interface. And we have done the embedding on the Ray documentation. It's essentially a chatbot that you can interface with in order to search documentation. Okay, so what are we here? AI platforms, unified AI platforms with Ray and Kubernetes. Lots of our customers, lots of teams, they adopt Ray and Kubernetes as a strategic initiative, right? Ray and Kubernetes is a strategic platform. What does that mean? So as we are seeing, AI is changing rapidly. We've repeatedly had to incorporate new innovations from statistical AI to deep learning, scaling that up to LLMs, and now today, like multimodal. You have the models growing larger, using more data, and there's more computational demand. Additionally, on the other side of it, you have an increasing variety of compute. I mean, NVIDIA is able to come out with new GPUs like every year, right? It's pretty crazy. So what does this all mean? Complexity is growing. The challenges are growing. And every organization, even if they've been doing AI for years, have still struggled actually to incorporate a lot of these new technologies and respond to the speed of demand. Right? So AI, it's still not done changing. It's still rapidly moving. So you have to future-proof, and that you do that with a standardized kind of unified platform. So we see many of our customers using Ray and Kubernetes to build that unified platform. It'll allow you to take advantage of AI, but still be able to respond to this fast-paced evolution. So let me start with why Kubernetes. Kubernetes it helps you orchestrate complex deployments. What is that, right? So firstly, Kubernetes has already been adopted as the trusted standard for DevOps. That's automating your deployment, your monitoring, and every time you need to update your application. This is going to be just as true, just as needed for ML ops or LLM ops, whatever ops you want to call it. You still want that automation to be able to have that CI/CD, right? And I mean, you can see some of the reasons it does it, but to kind of touch on two, flexibility. One, Kubernetes is an open, standardized API that you can easily and consistently use from going from your local laptop to data centers to cloud, right? And it has a very robust ecosystem of OSS tools for any workload, not just AI, non-AI as well, for monitoring, for logging, for security, all the good stuff, right? And again, all this is true, just as needed for AI and ML. And then let me touch upon scale, right? So Kubernetes it provides easy way to auto-scale up and down, right? Once upon a time, you might have thought scale was only needed for those really big companies like Google, right? But that's not true anymore. These models have become so large, you need so much data, that scale is pretty much a day of life for anyone working in AI. So Kubernetes helps you go from one workstation to thousands of GPUs, all the way back down to one workstation, whether you're a startup or whether you're a large company. And all of that is really about managing that complexity. Again, as you need more nodes, as you're building more models, as you're feeding to more applications, Kubernetes is a standardized platform, a compute platform that can handle any of those workloads. Yeah, stepping up, I'll hand it over to Kai-Hsun to talk more about Ray.
Thanks, Winston. I'm Kai-Hsun, and I'm from Nscale. And I am working in the recording and primarily focusing on the KubeRay and some record stuff. Now I will talk about what is Ray and why do we need to use Ray. Ray is an open source computation framework that's for scaling AI and Python applications. And why do we need to use Ray? I think the most important point is that Ray is pretty easy to use. You don't need to be a distributed system expert to use Ray. I think maybe most of you guys that learn how to use the MapReduce that in the school, and you can think like if you want to run a program in a distributed cluster with the MapReduce framework, you need to rewrite it into the map function and the reduce function. Now, it is very complex, but for Ray, you just need to change a bit of the line of code, and it will be almost the same for the program that's running in your local laptop and running in the distributed cluster. And the second is that because I think AI workload evolve very fast, so you need to have a general purpose computation runtime to cover the end-to-end life cycle, including like the data processing, training, tuning, and the serving, and to accelerate the time to production and the stable cost. And you can see the figure here. There is a Ray core. Ray core is the core of Ray. And then you see the Ray AI libraries. We built the AI library that's based on the Ray core. And then you can see the bottom is the deployment solution. Ray's approach to build deploy on both the virtual machine and the Kubernetes. You can deploy on like the GCP and deploy on the GKE and also on your on-prem cluster. And now I will introduce the Ray core. I think Ray core is that enable user to program in a distributed cluster as if they were working on their laptop. You can see like what is the most important element that's in your when you program in your laptop: a function, class, and a variable. And unlike the other distributed system, like the Spark, Spark is the abstraction is mainly designed for the data processing. Like Spark has a data frame. But Ray is designed for the general purpose programming. So it means that you can almost do anything with Ray. So in the Ray, we provide 3 API: the Ray task, Ray actor, and the Ray object. A Ray task is a remote version of the function, and the Ray actor is a remote version of the class. And the object is a remote version of the variable. And if you launch a class, an actor that's in the cluster, you can launch another task. And the task is not needed to be running in the same node as the Ray actor. So you can think like that. You just need to submit your program, and you just operate the whole cluster just as a laptop. So our slogan is that Ray is an infinite laptop. Yeah, and this is a very good example to show that how easy is it for the Ray. This example is from a user that's from Taiwan, a bank in Taiwan. And he is a data engineer from the bank. And he needs to handle a lot of the CSV file every day. So he decided to find a parallel computation solution. And he found Ray. And you can see in this example, you just at first is that you update the add an annotation on the function to convert the function into a Ray task. And then you change the function code to call the Ray task. And then that's all. You can parallelize the computation to 1,000 of the CSV file just with a few lines of code of change. Yeah. And the next is that we have already know what is the Ray core. And then we can talk about what is the Ray AI libraries. Some users, you can use the Ray core to build your AI applications, but you can also use the Ray AI library that's maintained by the Ray community. There are several AI libraries that's maintained by the Ray community, like Ray Data, Ray Chen, Ray Tune, and Ray Serve, and they cover the end-to-end life cycle of the ML. The Ray Data is primarily for the data loading, and like the batch inference and the embedding generation. And the Ray Chen is for the distributed training, and the Ray Tune is for the hyperparameter tuning. And the Ray Serve is for the model inference and the online service. Yeah, we currently know the Ray core and the Ray AI library. Now we should talk about how the deployment method that's in the Ray. Ray support to deploy on both the virtual machine and the Kubernetes. And I think in the open source side, most users deploy on the Kubernetes. And most of the Ray and Kubernetes users use the KubeRay to deploy the Ray. So I would say that KubeRay is the best solution for Ray and Kubernetes. I think maybe some of you have a context about the Kubernetes, so you may know what is the Kubernetes operator. KubeRay is a Ray Kubernetes operator. And the goal of this project is to enable the data and ML scientists to focus on the computation side, focus on their Ray script, their Python script, and the engineer focus on the Kubernetes side, focus on like the monitoring, focus on the logging, focus on the ingress. Yeah, and then with the KubeRay, data scientists can avoid to touch the YAML file and the Docker image, something like that. They can focus on what they want to do. And then we can talk about what is the future-proof AI platform that I think should have. The first is that I think for a unified AI platform is that we need to have a unified AI runtime. I think if you have a context about Kubernetes, most of the Kubernetes application is built based on the microservice architecture. I think it pretty makes sense to build the infrastructure based on the microservice architecture. But for the computation runtime, we want it to be more versatile to cover and the ML workload is pretty special is that it consists a lot of different workloads, including like the data processing, training, tuning, and serving. And in a different stage in the model lifecycle, it may require different infra requirements. For example, like if you want to use the data parallelism in the model training, you may require the GAN scheduling. And if you use the model serving, you may require like the auto scaling because it is an online service. You cannot predict that how many requests that will be in at a certain time. And you also need to implement like the high availability. So I think it is very versatile. So a unified AI runtime is very important. Without the unified AI runtime, you need to do a lot of like the YAML work to group the different stages together, and it will waste a lot of time and waste a lot of resource. And the second is that I think the future-proof AI platform should be flexible and general purpose enough, because I think the AI workload that evolve very, very fast. I think in the past 2 years, I heard about the people talk about like a reinforced learning, a stable diffusion, large language model, and a multimodal. And the different kind of the workload has a different infra requirement. As I said before, we have different stage, data processing, training, tuning, and serving. Each of them have a different requirement. And we can currently focusing on maybe the inference only. It also has a different requirement. Before the large language model, almost all the model can be scheduled on a single GPU or CPU. And in that case, most of the bottleneck is about the computation. So user may focus on that, hey, how do I reduce the floating-point operation? However, after the large language model, we require multiple GPU or multiple instances to serve a single model because it's pretty large. And because the large language model is the architecture is the transformer decoder, and the transformer decoder has the autoregressive nature. So it moves from the computation bound to the memory bound. So for inference only, we have a lot of different of the infra requirements. So that's why we need to have a very flexible infrastructure. And the third one is that we observe more and more users decide to explore the different hardware, not only NVIDIA GPU, but also the GPU from other vendor, and also like the TPU from Google. Yeah, and this is a use case to showcase that, a very simple use case to showcase why do we need to have a unified AI runtime. Sensora is a company about like the IoT, and you can think like before they adopt Ray, they have the 3 microservices. The first is the Golang microservice to do the model selection, and then a Python microservice to do the inference. And then the third one is a Golang microservice to do some business logic. And then they decide to use Ray to combine all of them together because Ray is the unified runtime for them. So they can avoid the serialization and deserialization between the different microservices. And the second is that they can share the resource between a different stage. And with that, they save the 50% of the cost. Yeah, so that's why I said that the unified AI runtime is very important. Yeah, this picture is the same as the Winston shows before. Yeah, so we think that the Ray and the KubeRay and the GKE is the unified AI platform solution. And then now we will try to demo an LLM application that is in the RAG-based with the Ray on GKE. Yeah, Winston?
Yeah, so to help get you started today, you can go to the Google Cloud Marketplace or to the GKE overview page and have like a one-click deploy wizard that will help automate getting KubeRay into your GKE cluster. Coming soon, as depicted here, we're actually going to make it even easier with just enabling one flag in the CLI or in the UI when you create a Kubernetes cluster. You can just say, yeah, I'm going to use Ray for this, and we'll handle all the deployment underneath to make sure that cluster can use Ray. Also, what's really cool is that it comes with a built-in integration for cloud laundering, cloud monitoring. And so there'll be default templates that you can see in your cloud monitoring dashboard to see your GPU usage and other kind of utilization within cloud monitoring observability dashboards.
Cool. Thanks, Winston. Yeah, I think it's pretty happy to see the GKE the officially support that's for the Ray and the KubeRay. Yeah, I think this diagram is also talks about that. It's about RAG, and we have a query, and we will retrieve some context from the vector database, and then also add the context that into the query to get a better result. And in this demo, the context, the information that's stored in the vector database is the Ray documentation, and then we will ask a Ray question about for this large language model. Yeah. And before we start the demo video, we should talk about what the demo video is going through. The first is that we will generate the embeddings. The first is that we pass all the Ray documentation from the online and then split into the multiple chunks. And then we use the Ray data to do the embedding generation. And I would say that the Ray data may be one of the best embedding generation solution in the market. And you can see we post a video. We post a blog is about how to use the Ray data or N-scale to do the embedding generation, and it will be cheaper than some online embedding generation service. Yeah, and then we store embeddings that's in the vector database. And the second step is that we have a query and we retrieve top key related context from the vector database. And step 3 is the generation. We add the context with the query and send it to the large language model and get a response. And here is that for the large language model, we have a multiple choice. For example, we can use a hosted service like the N-scale endpoint or the Vertex AI Gemini. Or we can also use the deploy with the Ray LLM. Ray LLM is an open source project that's maintained by the Ray community. Yeah, and now we can showcase like how to use the N-scale to deploy on the GCP, and then I will showcase that how to use KubeRay to deploy on the GKE. So both this is a host solution, and the other is the open source solution on the GCP. Yeah, this is the workspace of the N-scale. And then first is that we initial the vector database. And then we generate the embedding using Ray data. It includes like the chunk documentation into the multiple chunk. And then use a GPU to do the embedding generation. Yeah. Yeah, and after that, we check the vector database to see, the embedding successfully stored into the vector database, and then we generate the response. Yeah, we can see the response is that we ask the question is about Ray data. What is the default batch size of the map batches? And then we have the file URL. It is the file most relevant documentation that we retrieve from the vector database. And then the answer says that the default batch size for map batches is 1024. And then we can use a KubeRay demo is almost the same as we demo for the N-scale side. And we can see that how does this work. Yeah, I think that before I have already set out the KubeRay operator and set out the GK cluster and set out the Ray cluster that in the class in the Kubernetes cluster, and then so I directly to run the embedding generation. After finish the embedding generation, we check the vector database. Yeah, and then we check the response. Response is the same as the response that we get from the N-scale. This is because we set the temperature of the model to 0. So we will always get the same result. Yeah, now we can verify the answer. You can see we have the 5 contexts that I retrieved from the vector database, and we get the first one. And the website will look like the picture that's shown below. And then we can check the answer. Yeah, the answer is the 1024. And there are some further information. There is the demo is the same as our N-scale engineering blog that build the RAG-based LLM application. And then it also do a lot of experiment with like a different chunk size, different embedded model. And I think this is very informative. So feel free to check it. And the second is that I just open source the code that the demo shows. If you want to try it, you can follow the repository.
Cool. So we have a few ending slides here. Your feedback super important, helps us improve sessions over time. So if you go into the next app, you can give us good or bad feedback, all welcomed. So first QR code, there's some offers with Google Cloud. I'll pause for 10 seconds, scan it. get those Google Cloud offers. I suspect this might be in every sessions, but not sure. Next one, so GK and serverless, we would love to connect more with our customers. Your feedback helps guide our roadmap. So our PMs and our UX researchers would love to connect and maybe also give swag, usually something like that. So we'll pause. And last one, if you want to get more expert help on Ray and AnyScale, you can connect with Kai-Hsun and the rest of the AnyScale team.
Yeah, I think there are a lot of AnyScale that's in this session. So feel free to just chat with us that after a talk. Or we also have a booth that's in the in the Google Connect. So feel free to connect with us.
And yeah, thank you. So you can find the Slack channel, the KubeRay community, the Ray community. Also with GK, Ray and GK, if you just search, like Google search, Ray and GK GitHub.